Hi, welcome to Data Appreciation with Shino, and we'll be looking at a Google Skills lab for analyzing movie posters with BigQuery with remote models. So this is GSP1247, Google Cloud Self-Place Labs 1247. In this lab, we'll learn how to use BigQuery Machine Learning for interference with remote models, Gemini AI models to analyze movie poster images and generate summaries of these posters as part of proof of concept project. BigQuery is a fully managed AI data analytics platform that helps you to maximize value from your data and is designed to be multi-engine, multi-format, multi-cloud. One of the key features of BigQuery machine learning for interference, which lets you create and run machine learning models by using Google SQL queries. Gemini is a family of generative AI models developed by Google DeepMind that is designed for multimodal use cases. The API for Gemini gives you access to Mode 1, model name vision, and model name models. Running ML models using Google queries. The objectives of this lab, we will learn how to configure our environment account, use APIs, create a resource connection in BigQuery, create a dataset and object table with BigQuery for movie poster images, and create the Gemini remote models in BigQuery. So we have our setup requirements. Before we click Start Lab button, these are the instructions. You have access to internet browser, which we do have. We have the time to complete tab. And how do we start our lab? We click the Start Lab button. We open Google Cloud Console in incognito window. If we're already running in Chrome browser, we can see we're already in incognito, and the lab opens up resources and then opens another tab to show the sign-in page. So let's click on our Start Lab. We'll have our username and password given to us. Remember, we'll have to accept the terms and conditions when we get to the new tab. Now we would open our Google Cloud Console. So we have to open. So because we're already in incognito window, we would open the link in a new tab. You can also put it in a new window. So let's use the, because we want to be able to swipe between, let's just let's just open it in a new tab so that we'll have it right here so that we can be switching between the two. So let's see. So it has given us the access. Welcome to our new account. We understand the student's account. And see here we have its student rating. So next, what we'll do next is we'll configure our environment. The first thing we're going to do, and project to use our APIs. So already we've signed in. So next we would open the Cloud Shell terminal window. So I go to the terms. We will now go to our Cloud Shell terminal window. This is a cloud shell. So we'll first set our project ID and environmental variables in cloud shell. We'll run the following command. So we have to authorize to take us back to our window. Next, let's bring in operation. So we have our operation done. I think we should, let's see if we can have, let's just continue. Next, we're going to store the signed in Google user account in an environment variable. So to understand what this is, let's store the signed in Google account environment variable. Let's see what this means. So what is storing? So I think we could storing the signing user account in an environment variable. So let's just check what is an environment variable. The environment variable is a user definable value that can affect the way running processes will behave on a computer. Environment variables are part of the environment in which a process runs. So that's what we're doing next now. So now do that process. So that has been done, storing student account in the environment variable. So next we would enable Cloud AI Companion API for Gemini. So, so we can just have a look at what this means to enable. What what does it mean to enable? Or let's just look at Cloud AI Companion API, Robotics API. Cloud AI Companion API for Gemini and next. So let's see. So this is innovative, faster. It allows us to innovate faster with enterprise AI enhanced by Gemini models. So Vertex AI is a fully managed, unified AI development platform for building and using generative AI. Access and utilize Vertex AI CV plus over 200 other foundation models. So you can see it on Google. So what we want to activate, we, we open this in a new tab and we search for Vertex API. So this is what happens. Google Cloud takes you to the next, transfers your, you can see Vertex API. You can see our session was transferred to another browser tab. Let's just continue from here. So next, we want to enable the Cloud AI Companion API. Let's remove this so we can have a better look at it. Let's want us to do that again. Okay, I think I've seen where the error message came in. So we're now enabling the AI platform. So it says operation successful. The next, to use Gemini would grant necessary IAM roles to our Google Cloud Quick Lab user account. Here we're getting member user roles as a companion user. Okay. So the next thing we're doing is, so first of all, let's check after adding our roles if we've done everything required. So we've done everything. Now we're going to create a cloud resource connection so that we can work with Gemini 2.5 Flashlight and Gemini 2.5 Light models. So in Google Cloud Console, on the navigation menu, we're going to click on BigQuery. Let's minimize this. Go to our navigation menu, go to BigQuery. So from BigQuery, there's a welcome pop-up which we clicked on. To create a connection, we'll click add and then click connections to external data sources. So BigQuery, welcome pop-up, we click on done. Close this. So let me reduce font size here a bit. So from here, we're going to click on add. So we're going to click on add, then click connections to external data sources. You can click on plus add data, then use the search bar for data sources to search Vertex AI and click on the results. Vertex AI BigQuery Federation. So add data, search for Vertex AI, then BigQuery Federation. Then in the connection type list, we select Vertex AI remote models, remote functions, we click spanner, cloud records. So that has been done already. Then in the connection ID, we would enter Gemini Con for our connection. Next, in the location type, we select multi-region. Then from the drop down, select US multi-region. Multi-region, select US multi-region, which is what we have here. Use the default for other settings and click creations and go to connection. These are the defaults. For other settings, click on create connection. Next, we'll now go to connection. We'll take us to the connection. While you're doing that, let's check our progress. Now, the next task we're going to do is to grant IAM permissions to the connection service account. So, what are IAM permissions? IAM permissions are available on all services. Each IAM permission. So let's see what are IAM permissions. IAM provides additional predefined rules that gives granular access to specific Google Cloud resources. These rules are created and maintained by Google. Google automatically updates their permissions as necessary, such as when Google adds new features services. So we'll go to now grant permissions. So in the Google Cloud Console, we'll navigate to the navigation menu. We'll click on IAM and admin. We'll click on grant access in the new principals field. So let's go there. Let's go to IAM and admin. Grant access, new principals field. We'll enter the service ID we copied earlier. Service account ID which we copied earlier. Remember, this is our service account ID. Okay, we were supposed to be in the connection. So let's go back to our connection. So our service account here, but let's go to our connections so we can look at our service account ID. So let's go back to our connections. So we need our service account ID. Let's go back to this is our connection ID, service account ID. So this is our service account ID. Remember, we have the connection ID, we have the service account ID. So what we're told to do is to copy the service account ID. So we've done here. Then we go to IAM. Then we click on grant access. The input field will enter the service account ID we copied earlier. Service account ID. Next, we would assign roles. So we'll select in the role field, we'll enter Vertex AI and then select Vertex AI user role. Vertex Vertex AI user. Next, what we'll do is save. We'll check out progress. You can see our policies are updated. Take a few minutes for the changes to become active. It's updated here for us. Let's go and check out progress. So the next task is to create the dataset and object table in BigQuery for movie poster images. So we want to create the dataset and object table in BigQuery. So in the Cloud Console navigation menu, select BigQuery. In the Explorer panel, for this, we'll select View Actions. So go back to navigation menu, BigQuery. Under Explorer, we have this. We'll click on View Actions next to Datasets. Next, we'll select create dataset. So we create datasets to store database objects, including tables and models. So in the create dataset pane, we enter the following information. The dataset ID is Gemini demo. So we go to ID as Gemini demo. Location is here, it's multi-region, and the multi-region is US. Region. Next, we leave other fields as default, and we click our dataset. Let's create dataset. Next, we're going to create the object table. We'll use SQL query. So we'll click on the create new SQL query, and then we'll use this query here. Run the query from here. Run has processed it, so we can run it. The statement created a new table name posters. You can see select new posters and review the schema and details. Let's go to the table. Okay. Hierarchy data here. So next, what we do is check our progress. So for the next task, we're going to create the Gemini remote models in BigQuery. Remember, we created our table. Now begin work with it. Now we're going to create remote models for Gemini 2.5 flashlight and Gemini 2.5 tablet vision in query. So next, we're going to create a new SQL query. Yeah. Let's have a dry run. The next thing we're to do, the result is the Gemini Lite model created. And we'll see it added to the Gemini demo dataset in the model section. Let's go to our model section. You can see the model type, the model ID, date created, and the location. So you can see our model details, model expiration error, remote connection, remote endpoint, training options, many actual iterations we've had, label columns and feature columns. Now we're going to create a Gemini 2.5 flashlight vision model. Query editor, run it. So in Classic Explorer, we'll click on Gemini Light Vision model and review the details of the schema. Model, come back to the Or so the result is the Gemini Light Vision model created. You see it added to the Gemini demo dataset in the model section. So if we go to our models section, you can see it here, Gemini Light, Gemini Light Vision. Come to our details, page, created location, model details. Okay, so let's check our progress. The next time, to prompt Gemini to provide movie summaries for each poster. In this task, we'll use Gemini 2.5 Flash and Vision to analyze the movie poster images and generate summaries for each. So what we're doing is going to analyze the images with Gemini. Click on the query. The query editor will create this query. So we have create table, select URI from our model and this table. Our temperature is 0.2. The result is the movie poster results table created. So let's go into that. Run. Go to read the cloud storage file to provide connection ID with correct permissions. So Gemini has been embedded. Pass it to our query. Because we're having the connection ID permissions error. So in the new principles, we're going to choose cloud storage and storage object viewer and click save before we run our query again. So let's go back to our ID. So let's it. So let's see. We'll come back here. Our ID. Let's go to IAM. It will say we have unsaved work, so let's just save some of this. Let's see. We have these are the restrictions. Just trying to see if we can save our queries. Let's go straight there and see if it let's just leave. So we'll click on, we already have a Vertex AI user here. Just to show if we actually granted. Just click on grant access. Same service ID. So the role which we're to put in is cloud run viewer. The version of policy you're currently is not updated. The following changes have been committed in that user. So let's see. Cloud. Select a role. Choose cloud storage object viewer. With cloud storage object viewer. Cloud storage storage object viewer. Storage user. Program storage object was storage object viewer. So let's go back to BigQuery and run. Let's see if our policy was updated. We have permissions now, and we have permission. So table. So what we'll do next is in class explorer, we'll click on move process results table to review the schema. We'll click with stop sign plus sign to create a new SQL query. Let's create a new SQL query. Let us run it. We have our results. The result is rows for each movie poster with the URI cloud run storage location. You can retrieve these results in a more readable way by using the next query. our next query. You can see it's not that readable. Let's use the next query. The, now we'll create a table with the query below. Let's see it better now. You can see title and year columns for each row. You can see title and year. Next, we want to prompt Gemini Lite to provide movie summaries. So let us do this now. So we're told we'll get a similar result from this. So now we also have prompts, like the year and title. Now the prompt used with Gemini is displayed in the prompt column and the result of using this prompt. Press. Now what we'll do next is generate text embeddings using a remote model. First, we'll create the remote model. We'll use the remote embedding 001. So creating text embeddings. In the query result, we'll go to run this query. Within the same project. What we're to see is text embedding model created and appears in Explorer underneath the Gemini demo dataset. Next, we're going to generate text embeddings for the title and year associated with the posters. Let's run this. See title and year. Now note that the ML generate embedding function is used to generate the embeddings. This function takes three arguments. The first argument is the name of the model to use for generating the embeddings. Second argument is subquery that selects the text content to be embedded. The third argument is the struct that specifies the output format of the embeddings. You can view the results of the query using this new query. Here it is. Next, we're going to generate text embeddings for a subset of the IMDb dataset. We'll create a new view that contains only the movies in that dataset that were released prior to 1935. You can see it here. We're creating to replace this as with reviews, selecting review movies ID, title start here, reviews from the BigQuery data MB reviews, left joining this data where the year is less than 1935. So the results in even contain lists of distinctive movie ID titles and year of release from BigQuery reviews. Let's run new query with the following command. Next, I'm going to match the movie poster images to IMDb ID using BigQuery vector search. You'll see from vector search table top k greater than equals to one distance type cosine. Here from results, I have movie title, poster title, poster year, and the IMDb title and the year. So if the IMDb title is different, we'll notice it from here. Like this, we have back September 4, which is the boat leaving the port of the French movie. You can see the difference between poster title and movie title. So this query uses vector search function to find the nearest neighbor in the Gemini embeddings. Query can be used to find the most similar movie in the IMDb dataset for each of the following identities. So we'll create and run a new query to join some additional information on movie ratings provided by the IMDb public dataset. Remember, Gemini is in the IMDb public available dataset, which BigQuery is accessing. Let us run this. So now we have more information. We have votes, rating, distance, year in the movie ID, year, the title, poster, year, and poster title. Let us check our progress. So we have successfully created an object table for our poster images in BigQuery, created using Gemini models, and we use the models to prompt Gemini to analyze images and provide movie summaries. We generated text embeddings from movie titles and used embeddings to match movie posters to the related movie and the dataset. So thank you very much, and I end the lab. See you in